If you close your eyes tonight and picture the vast universe, you might imagine endless stars scattered like jewels against a black canvas. But what if I told you the canvas itself isn't empty at all? That the space between stars is not silent nothingness, but a sea of invisible energy quietly holding everything together? Our ancestors called it ether, mystics called it spirit, and scientists now call it fields or dark energy. Yet words only touch the surface. The truth is, what looks like emptiness is more alive than we dare to imagine. And tonight, we'll wander into that unseen ocean, the silent ocean that surrounds every star. Stars seem to float alone, shining against an endless darkness. But that darkness isn't truly silent. It's more like a vast ocean that every star rests upon. Imagine being in the middle of the sea at night. The waves are too quiet to hear, yet they are always moving beneath you. The universe is the same, carrying stars on invisible currents that ripple through space itself. Astronomers once thought the cosmos was mostly made of what they could see: stars, planets, gas, and dust. But when they measured carefully, the math didn't add up. Something unseen was balancing the scales. It was as if the stars were ships, and the ocean beneath them was hidden, yet powerful enough to shape their journeys. This ocean doesn't glow, it doesn't sparkle, but it reveals itself in the way galaxies move. When stars orbit the center of a galaxy, they should drift apart like dancers too far from the music, but instead they stay bound together, as if clasped by an invisible hand. That hand is the silent ocean, spread everywhere, even here, around us. You might wonder, if it's everywhere, why can't we feel it? The truth is, we do, indirectly. Gravity itself bends to its presence. The rhythm of cosmic expansion obeys its pressure. Even the atoms inside us are immersed in this invisible tide. We don't notice it for the same reason a fish doesn't notice water. It is too complete, too all-encompassing. And the thought lingers, if this ocean surrounds us all, then perhaps the universe isn't a cold void at all, but a warm sea where everything floats together in silence. Why emptiness is never truly empty. When we look up and see the night sky, it feels like empty space stretches endlessly. But emptiness is never truly empty. Even in the quietest corners of the universe, the void hums with hidden energy. If you could zoom in beyond atoms, beyond particles, you would find space bubbling with invisible vibrations like the surface of boiling water you cannot see. This discovery startled scientists. For centuries, vacuum meant nothing. Yet quantum theory whispered a different story, that even in the absence of matter, energy flickers in and out of existence. Tiny bursts appear, vanish, and reappear again, a restless dance that never pauses. It's like a theater where the curtain never fully closes. Imagine standing in a still forest, no birds singing, no wind stirring the leaves. You think it is silenced until you notice the faint hum of insects or the pulse of your own heartbeat. The void of space is similar, it feels silent, but when we listen deeply enough, we find it alive with hidden rhythms. This invisible fullness has real effects. It pushes on galaxies, bends the path of light, and even decides how stars are born. Emptiness is not the absence of things, but the stage on which all things emerge. It is not dead space, it is fertile ground, endlessly ready to give rise to something new. And the most haunting thought of all is this: if emptiness is alive, then perhaps nothingness itself is the source of everything we see. The mystery of the unseen background. The background of the universe is like the canvas of a painting. We don't often think about it. Our eyes go straight to the brushstrokes, the bright stars, the glowing galaxies. But a canvas holds the art together. Without it, the painting could not exist. In the same way, the unseen background of the universe quietly holds the cosmos in place. Cosmic microwave background radiation and a faint afterglow from the birth of the universe was our first glimpse of this hidden layer. It's like finding ancient fingerprints on the wall of time. That background light whispers a truth. Space is not blank, but woven with patterns set long ago. Every star, every galaxy still follows that pattern today. Scientists map this unseen background like explorers charting a coastline. What they find are subtle ripples, variations that shaped where galaxies would form, where clusters would grow, and where empty voids would remain. This background is like the first sketch beneath a masterpiece, invisible to the eye, but guiding the strokes forever. Yet the mystery deepens. Beneath even that ancient glow lies another background, an ocean of quantum fields, invisible but everywhere. Unlike the faint relic of light, these fields are not a memory of the past. They are alive right now, buzzing at every point in space. It leaves us with an unsettling thought. What we call reality might only be the surface. The true universe could be the unseen background, quietly scripting the play while we watch the stage. How energy hides in plain sight. Energy is often thought of as light, heat, or movement, something you can feel, measure, or see. But the most powerful energy in the universe hides in plain sight, disguised as the space between things. It's as if the richest treasure was stored not in the gold itself, but in the air around it. One of the most striking examples is dark energy. It makes up most of the universe, yet it cannot be bottled, seen, or touched. It acts not like a visible flame, but like a silent pressure stretching the fabric of space itself. Every second, it pushes galaxies farther apart. Yet we notice only when we measure distances across billions of years. Think of how air surrounds us. We do not see it, but it shapes every breath, every sound, every storm. Invisible energy is the universe's air, everywhere, quietly in control. Without it, galaxies would collapse inward or freeze in stillness. Instead, they drift, expand, and evolve under its hidden hand. The irony is that we live surrounded by this energy, immersed in it, but only recently began to acknowledge its existence. It's like discovering that your entire life has been spent on a ship you never realized was floating. And so the question becomes, if such energy hides in plain sight on cosmic scales, could there also be layers of hidden energy closer to us, even inside us, that we have yet to notice? The forgotten whispers of the quantum field. At the smallest scale, beneath atoms and particles, lies the quantum field, a restless fabric that never goes silent. To some it is mathematics, to others it is mystery, but to the universe it is the very breath of existence. Every particle we know, every bit of matter rises like a ripple on this invisible field. Physicists once thought particles were the foundation of reality, but the deeper they looked, the more they realized particles are only temporary excitations of something deeper. The true foundation is the field itself, humming beneath all creation. It is like waves on the sea. The wave is visible, but the sea is what truly exists. These fields are not idle. They whisper constantly, spawning virtual particles that flicker in and out of being. We cannot hold them, but we can see their effects in experiments. A particle here, a shift there, echoes of an invisible choir we cannot hear directly. It's as if reality has a hidden heartbeat. The forgotten whispers of this field touch everything, including us. The atoms in our bodies, the light in our eyes, even the spark of thought in our minds, all of it rests upon this invisible foundation. We are not separate from it. We are woven into it. And once you realize that the very space around you is alive with these whispers, the night sky feels less cold, less empty. You begin to wonder if what we call energy is not something outside us, but something we are already part of. When scientists first realized the void has weight, for centuries space was believed to be nothing more than an empty backdrop. But then experiments began to whisper a different story. When physicists measured the behavior of subatomic particles, they discovered strange shifts, as if the vacuum itself was leaning in. It was as though nothingness had a presence, not weight like a stone, but a subtle pressure that could not be ignored. One of the most startling clues came from the Lamb shift in atomic hydrogen. A small, unexpected energy change hinted that the vacuum was influencing electrons. Scientists realized the void was not passive, but active. The background of space carried hidden weight, shaping matter itself. The very concept of emptiness was turned upside down. Think of it like a tablecloth beneath a glass. You don't see the cloth when admiring the glass, but if you tug it, the glass shifts. The void works the same way, invisible but always present, always tugging at the universe in quiet ways. The deeper scientists probed, the clearer it became that the fabric of reality is never neutral. This realization left many unsettled. If emptiness had energy, how much energy was there in all the vast spaces of the universe? The numbers suggested something staggering, a reservoir so immense that our visible universe looked tiny in comparison. The weight of the void was heavier than all the stars combined. And once this truth landed, physics itself was never the same. The void was not absence. It was a player in the game. Silent, unseen, but holding enormous influence over the fate of galaxies and the march of time itself. Invisible rivers shaping galaxies. When astronomers mapped galaxies, they expected stars to orbit like planets do around the sun, slower the farther they were from the center. But what they found was startling. Stars on the edges moved just as fast as those near the middle. Something unseen was holding them in place, like invisible rivers guiding their dance. These hidden currents became known as dark matter. It doesn't shine, it doesn't reflect, but it pulls with gravity. Without it, galaxies would scatter apart, their stars flung loose into the cosmic night. Instead, galaxies swirl as if wrapped in invisible halos, rivers of unseen energy shaping their motion. Imagine watching leaves floating on a stream. You cannot see the water itself, but the leaves reveal its flow. In the same way, stars reveal the presence of these hidden rivers. We only know they exist because of the paths matter takes around them, following channels carved by something we cannot touch. This realization was humbling. Most of the universe's structure is not built by what we see, but by what we cannot. The bright spirals of galaxies, the graceful arcs of clusters, all of them are only visible ripples on a much deeper current of invisible energy. And so every time we gaze at the night sky, we are looking not at solitary stars, but at travelers held within invisible rivers that stretch far beyond sight, guiding their journey through the endless dark, the secret dance beneath starlight. Every star shines, but its dance is not its own. Beneath the visible starlight lies an unseen choreography, written by gravity, dark matter, and quantum whispers. The universe may look chaotic at first glance, but the deeper we look, the more we see a secret dance, a rhythm woven by invisible energy. Clusters of galaxies move in ways too precise to be random. Their orbits suggest hidden hands pulling strings across millions of light years. The energy behind this dance is not chaotic, but patterned, as though the universe itself prefers harmony over disorder. And yet that harmony is woven from silence. Think of a flock of birds in the evening sky. From the ground it looks like chaos, but each bird adjusts to the one beside it, creating a flowing dance that feels choreographed. Galaxies behave in a similar way, responding not just to visible forces but to invisible ones humming beneath their light. The starlight we admire is only the surface performance. Beneath it, dark energy pushes, dark matter pulls, and quantum fields whisper. Together they form a hidden music, inaudible but powerful enough to set the tempo of creation itself. Starlight is the melody, but the invisible energy is the beat. It is this dance, silent, patient, eternal, that gives the universe its shape. Without it, stars would drift like scattered dust. With it, the cosmos becomes a grand ballet, moving endlessly to a rhythm we are only just beginning to hear. Why light alone doesn't tell the whole story. For much of history, light was our only guide to the cosmos. We built telescopes, gathered photons, and believed that what we saw was all there was. But light, for all its beauty, is only one storyteller, and it tells an incomplete tale. Beyond what light reveals, invisible energy shapes everything we cannot see. When astronomers studied galaxy clusters, they found that the visible light from stars made up only a fraction of the total mass. Light was telling us about the sparks, but not about the fuel feeding the fire. The hidden bulk, unseen energy and matter, was missing from the picture. It is like listening to a song through a broken radio. You hear fragments of melody, but the bass line, the depth, the richness are lost. Light gives us the melody of the universe, but invisible energy is the bass, the foundation that makes the song whole. Without it, we hear only half the music. This realization changed astronomy forever. Telescopes were no longer just about capturing light, but about detecting what light does not show. Gravitational lensing, cosmic microwave background, and particle detectors became tools to read the silent handwriting in the dark margins of space. The truth is, light was never meant to tell the whole story. It is only the visible ink on a page filled with invisible words. And once we learned to sense those unseen lines, the universe became a much deeper, stranger, and more beautiful book than we had ever imagined. A universe held together by what cannot be seen. When you step back and look at it all, a haunting truth emerges. The universe is not held together by what we see, but by what we cannot. The stars, the planets, even our own bodies are only the glittering tip of an iceberg, floating on an invisible mass that keeps everything bound in balance. Dark matter keeps galaxies from flying apart. Dark energy stretches the very fabric of space. Quantum fields hum beneath every particle, sustaining the theatre of existence. What we call reality is only the glowing surface. The scaffolding that holds it all together is unseen. It's like looking at a cathedral at night. You see the stained glass windows glowing, the flicker of candles inside, but the great stone walls that hold it all up remain hidden in shadow. The universe works in much the same way. Light dazzles us, but shadow carries the weight. This truth can feel unsettling, even lonely at first, but there is also comfort in it. If the unseen holds everything together, then we are never really adrift. We live in a universe of invisible support, surrounded by silent strength that never leaves us. And perhaps that is the most poetic secret of all. The unseen doesn't just exist. It embraces us, carries us, and reminds us that even in the darkest space we are never truly alone. The ghostly hand of dark matter. Imagine walking through a forest at night. You see the glow of fireflies, the outline of trees, but you feel the wind tugging at your clothes, even though you cannot see it. Dark matter is like that invisible wind, a ghostly hand pulling at the universe. It has no light, no reflection, yet it shapes everything we see.
Astronomers found its presence when galaxies spun too fast for their visible mass. Without an unseen anchor, those galaxies should have torn apart long ago. Something ghostly was holding them together. That something unseen and untouchable became known as dark matter. It doesn't interact with light or ordinary matter in the way we understand. It passes through us, through Earth, through stars, without leaving a trace except for its gravitational pull. Imagine an invisible scaffolding hidden inside a building. You don't see it, but it prevents the roof from falling. Dark matter is that hidden architecture of the cosmos. And what's haunting is its abundance. It outweighs ordinary matter 5 to 1. Everything we know, the planets, the stars, the galaxies, is just the minority. The majority is this unseen hand, quietly carrying the universe on its palm.
The mystery remains unsolved. What is it made of? Why does it exist? We don't yet know, but we do know this. Without it, there would be no galaxies, no stars, no us. We live in a universe sculpted by a ghostly presence that refuses to be seen. How galaxies spin faster than they should. When scientists first measured the speed of stars circling galaxies, the results defied reason. Far from the center, where gravity should weaken, stars still raced just as fast. It was like a merry-go-round where the horses on the edge moved as quickly as those near the pole. Something was wrong, or perhaps something invisible was right. In classical physics, the farther you are from the center, the weaker the pull should be. That's how planets orbit the sun, but galaxies refuse to obey this rule. The outer stars should have drifted away into space, yet they clung tightly, spinning in unison. The only explanation was that galaxies were heavier than they looked, not from the stars we could see, but from a massive halo of invisible matter surrounding them. This unseen cloak gave galaxies their grip, their speed, their ability to spin without breaking apart. It was like discovering that the stage beneath the dancers was far larger than anyone realized. Astronomers tested this theory again and again. Gravitational lensing, the bending of light by mass, revealed arcs of light around galaxies, proving the invisible weight was real. Dark matter was not speculation anymore. It was a fact woven into the cosmos. And so, every time we admire a spiral galaxy glowing in the night, we are not just seeing stars, we are seeing the visible surface of a hidden wheel, spinning far faster than it should, powered by the silent grip of something we cannot see. The missing mass no telescope can find. When scientists tallied up the matter in the universe, they expected the numbers to match, count the stars, the gas, the dust, and that should account for the cosmos. But the numbers fell short. A vast amount of mass was missing, hidden somewhere no telescope could find. This missing mass became the great cosmic riddle. At first, some thought the missing matter might be faint stars or black holes too small to detect. But even when they added up every candidate, the math still fell short. Something larger, stranger was missing, a sea of mass invisible to every instrument we had. This was not an absence of data, it was the discovery of something greater than everything visible combined. Like standing in a library where the shelves you see are only a fraction, while a vast hidden archive lies behind locked doors, unseen but real. The missing mass was not just a gap, it was the bulk of reality. Scientists called it dark matter, but the term was more an admission of ignorance than a description. Dark because it did not shine. Matter because it pulled with gravity. But beyond those hints it remained elusive, like a shadow we can feel but never touch. And yet that missing mass makes everything possible. Without it, galaxies would fly apart, clusters would collapse, and stars would never settle into their constellations. The invisible outweighs the visible, and that truth reshapes how we understand everything we are. Tracing shadows with invisible threads. If you cannot see something directly, you trace it by its shadow. That's how astronomers learn to study dark matter, by watching the way it bends light, stretches galaxies, and pulls stars along invisible threads. The universe became a spiderweb of unseen filaments, connecting clusters across billions of light-years. Gravitational lensing was the key. When light from distant galaxies passed near a massive cluster, it bent, not just around the visible matter, but far more than expected. This bending revealed something hidden, a vast skeleton of dark matter threading space together like an invisible net. Computer simulations brought this vision to life. Instead of galaxies forming in random clouds, they grew along filaments of unseen mass, where gravity pooled and pulled matter together. The universe was not scattered but structured, its shape carved by threads no one could see with their eyes. This cosmic web changed our picture of reality. The stars we admire at night are not isolated sparks, but beads strung along unseen wires. Every shining point is part of a larger design, drawn by the hands of something invisible, and those threads are stronger, longer, and deeper than light can ever reveal. It feels humbling to realize we are living inside that web. Stars, planets, and even us, suspended like dust in a net woven by shadows. The very pathways of galaxies are mapped not by what we see, but by the invisible currents binding them together, the silent scaffolding of the cosmos. Every great structure rests on scaffolding, the hidden framework that carries its weight while the visible parts shine in the light. The cosmos is no different. Its galaxies, clusters, and stars are built upon silent scaffolding made of invisible matter and energy. Without it, the universe would collapse into chaos. This scaffolding is dark matter, stretching like bones beneath the skin of reality. Galaxies cling to it, grow upon it, and move along its framework. It is not decorative, it is essential. Without it, no stars would form, no galaxies would hold, no structures would survive. Think of ancient cathedrals, their stained glass glowing, their arches soaring into the sky. What you see is the art, but behind that beauty lies stone, mortar, and beams holding everything in place. The stars are the stained glass. Dark matter is the stone. Without it, the light could never shine where it does. This silent scaffolding even reaches us. The Milky Way is not free-floating, but bound within its dark halo. Our solar system circles inside that invisible framework, unaware of the silent arms holding us. Every breath we take, every night we look at the sky, we are standing on hidden ground. And perhaps that is the lesson. What matters most in the universe is not always visible. The cosmos, like life itself, rests on scaffolding unseen, a quiet strength that carries everything, even when we forget it is there. Dark energy, the stranger, still beyond dark matter. If dark matter was unsettling, dark energy was stranger still. While dark matter pulls galaxies together, dark energy pushes the universe apart. It is a quiet pressure that stretches space itself, faster and faster, as though the cosmos is breathing outward with no plan to stop. The discovery came by accident. In the 1990s, astronomers measured distant supernovae expecting to see the universe slowing down, weighed down by gravity. Instead, they found the opposite. Expansion was accelerating. Something unseen, something powerful was pushing everything away. A repulsive energy filling space itself. It was unlike anything known. Dark energy didn't behave like particles or matter. It wasn't clumped in galaxies. It was smooth, uniform, everywhere at once. It didn't pull, it pushed. If dark matter was the anchor, dark energy was the rising tide, lifting everything farther apart. Scientists calculated that dark energy makes up nearly 70% of the cosmos. The universe we see, stars, galaxies, gas, dust, is only a tiny sliver. The real ruler is the invisible pressure that expands space faster every day. The cosmos is dominated by what it hides, not by what it shows. And so dark energy remains the greatest enigma of all, an invisible force, silent and omnipresent, shaping the universe's fate while we stand beneath the stars, unaware of the ground slipping away beneath us. A force that pushes space itself apart. Imagine inflating a balloon. The rubber stretches, carrying everything on its surface farther apart. Galaxies live on such a surface, and dark energy is the breath that inflates it. The difference is, unlike air in a balloon, dark energy does not thin out. It stays constant, no matter how much space grows. This makes dark energy unnerving. With every passing moment, more space means more dark energy, and more dark energy means faster expansion. It is a runaway process. Slow to begin with, but unstoppable. The universe is not just growing. It is accelerating into something even stranger. Astronomers once dreamed the universe might one day collapse back in a big crunch, stars drawn inward again. Dark energy shattered that dream. Instead, the future points toward endless separation, a universe stretching until galaxies drift so far apart that their light never reaches each other. Even now, light from the most distant galaxies is slipping beyond our horizon. A silent farewell. In the far future, only the closest stars will remain visible. Everything else will be carried away by this invisible force, leaving a sky far emptier than ours. It leaves us with a paradox. We live in a time when the universe is most visible, when starlight still reaches us before dark energy carries it away. We are witnesses to a brief window when the cosmos is still open, before the curtain begins to close. The universe's quiet breath of expansion. The expansion of the universe is easy to forget. From our small world, the stars look fixed, the constellations unchanged. But beyond the stillness lies a quiet breath, the stretching of space itself. Every second, galaxies drift farther apart, not because they move, but because the fabric between them grows. This expansion is not an explosion. Explosions fade, but the universe's breath does not. It is steady, continuous, relentless. Even empty space expands, carrying with it the galaxies like lanterns drifting apart on a dark sea. We sit on one of those lanterns, barely aware of the current. What's remarkable is how silent it is. No roar, no sound, just the patient stretch of distance. The Earth circles the Sun orbits the Milky Way, but beyond it all, the universe itself inhales, and galaxies drift farther away with each cosmic breath. This breath leaves imprints everywhere. In the faint afterglow of the Big Bang, scientists can measure how the universe stretched. In the distances between galaxies, they see the evidence of a quiet expansion. Even in the way starlight reddens as it travels, we hear the echo of this breath. And though we cannot feel it, we are carried by it every moment. The quiet breath of the universe is also our own story, for without it, stars, galaxies, and even us would never have come to be. Energy without particles, presence without form. Dark energy challenges our imagination because it doesn't behave like anything familiar. Energy usually comes with particles, light with photons, matter with atoms, heat with vibration. But dark energy is energy without particles, presence without form. It is like a song with no singer, a current with no river. This makes it almost ghostly. We cannot point to it, cannot bottle it. Yet its fingerprints are everywhere in the universe's expansion. It does not clump, it does not shine, it does not move. It simply is. The purest example of energy existing without a vessel. For physicists, this is deeply puzzling. Does dark energy arise from quantum fields, from the fabric of space-time itself, or from something beyond our theories? Each possibility feels like standing at the edge of a vast ocean, unable to see what lies beneath the waves. The strangest part is that dark energy may not even be constant. Some theories suggest it could change over time, growing stronger or weaker. If it grows, the universe's expansion may rip everything apart. If it weakens, gravity may one day regain control. Our future rests on an invisible presence with no form. And so we live with a cosmic riddle, energy unlike any other, shaping everything while revealing nothing. A reminder that the universe is stranger than our categories and far older than our understanding. The greatest puzzle in modern physics. When scientists gather to speak of the universe's greatest mysteries, dark energy sits at the top. It is not only powerful, it is unexplainable within the laws we know. The greatest puzzle in modern physics is not what we see, but what we cannot. Every measurement of cosmic acceleration points back to it. Every attempt to fit it into equations reveals contradictions. The numbers don't match, the theories stumble. It's as if the universe is teasing us, showing us effects without revealing the cause. A magician's trick performed on the scale of galaxies. Some call it the cosmological constant, Einstein's reluctant addition to his equations. Others imagine new forces, new fields, new dimensions. Some even whisper that our universe might be one bubble in a larger sea, and dark energy is the tension between worlds. None of these answers are proven, but all remind us how small our knowledge is compared to what lies beyond. For all our technology, dark energy remains untouchable. We can measure its effect, but not its essence. It is like feeling the warmth of a fire you cannot see, knowing it must be there, but unable to step closer. A mystery that humbles every mind that confronts it. And perhaps that humility is the lesson. The greatest puzzle in physics reminds us that the universe is not ours to conquer, but to listen to, patiently, quietly, like a student leaning in to hear a story too vast for words. 0-point fields and the hum of nothingness. Imagine stripping the universe bare, removing every star, every atom, every trace of light. You'd think you'd be left with pure emptiness. But physics says even then, silence would not exist. The vacuum itself hums with 0-point energy, the faint vibration that never turns off. This hum is not optional. Even at absolute zero, when all heat is gone, particles still quiver, refusing to be still. It's as if the universe cannot bear silence. There is always a background note, a low, eternal hum woven into the fabric of space. Scientists first encountered this while studying quantum mechanics. Equations insisted that energy would remain even in perfect vacuum. The idea was almost absurd, nothingness full of something. Yet experiments confirmed it. Space is never empty and it is restless, vibrating invisibly at every point. Think of a violin string. Even when it rests, it is under tension, ready to sing at the slightest touch. The 0-point field is like that. A string stretched across the cosmos, humming softly whether or not we listen. And perhaps that is why silence in the night sky feels so alive, because beneath it, the hum of nothingness is always there, carrying the quiet heartbeat of creation itself. How emptiness buzzes with hidden activity. If you could shrink yourself smaller than an atom and peer into empty space, you wouldn't see stillness. You'd see flickers, sparks of energy flashing in and out, like fireflies in a summer field. Emptiness buzzes with hidden activity, too quick and too small for our senses to notice. Quantum fluctuations create pairs of particles and antiparticles that pop into existence, dance briefly, then vanish. They leave behind traces, tiny ripples that shape the universe. What looks calm from a distance is, up close, a restless foam of creation and disappearance. It's almost mischievous. Space pretends to be still, but at the quantum level it is busier than any marketplace. Virtual particles rise and fall endlessly, proving that nothing is not a void, but a stage of constant rehearsal for reality itself. The buzzing of emptiness isn't just a curiosity. It affects atoms, shifts energy levels, and even influences the forces between objects. What we call vacuum energy may be the invisible foundation that holds physics together, unseen but indispensable. And once you realize this, even the blackness between stars feels different. Not empty, not dead, but alive with a secret rhythm, buzzing always just beyond the reach of our eyes, the restless vacuum beneath our feet. We tend to think of space as something far away, the dark between planets and stars. But the restless vacuum is here too, beneath our feet, around us, inside us. Every inch of space, no matter how small, vibrates with invisible energy. Even the space within atoms is not silent. The electrons around a nucleus swim in a sea of fluctuations. What we call matter is mostly space, and that space is never truly empty. We are, quite literally, beings made of restless vacuum, walking in a universe that never pauses. This thought unsettled even Einstein. He once tried to erase vacuum energy from his equations, calling it unnatural. Yet it kept creeping back, refusing to be ignored. Reality itself seemed determined to remind us there is no such thing as perfect stillness. It makes you look differently at the ordinary. The air you breathe, the chair you sit on, the very space you move through, all are soaked in this restless vacuum. It is invisible, untouchable, but it is everywhere, and that means the great mystery of the cosmos is not out there beyond the stars. It is here, woven into the space between every heartbeat, every breath, every atom of our being. When fluctuations shape entire worlds, small things often carry the greatest weight. Quantum fluctuations, tiny bursts of energy in the vacuum, may have shaped the universe itself. At the dawn of time, these ripples grew into galaxies, stars, and worlds. The largest structures in the cosmos were seeded by the smallest flickers of emptiness. During cosmic inflation, when the universe expanded faster than the speed of light, quantum ripples stretched into vast patterns. Like wrinkles on a balloon, they froze into the fabric of space, becoming the blueprint for galaxies billions of years later. This idea is almost poetic. Everything we see, every world, every star, was once just a fluctuation in the vacuum. Nothingness whispered, and out of that whisper came suns and planets and us. The grandest designs of the universe are traced back to the trembling of emptiness. Even today, we can see those imprints in the cosmic microwave background, faint patterns of hotter and cooler spots across the sky. They are fossilized fluctuations, proof that the restless vacuum shaped everything we know. And so the next time you look up at the Milky Way, remember those stars began as whispers in the silence, tiny fluctuations that grew into a universe alive with light, particles born and gone in an instant. In the restless vacuum, particles do not stay long. They are born, live for a heartbeat of time, and then disappear, leaving no trace except the effects they cause. These virtual particles may be fleeting, but they shape forces, push objects, and keep the universe alive with hidden motion. This process is constant. A particle and its twin opposite, an antiparticle, appear from nowhere, collide, and vanish. It is a cosmic dance happening everywhere at once, too quick for our eyes, too brief for direct capture, yet too real to deny. Even though they vanish, these particles influence everything. They shift the strength of electromagnetic fields, tweak the forces inside atoms, and even contribute to the weight of the universe. Their presence is like whispers in a conversation. You may not hear the words, but they change the meaning of everything else. For physicists, virtual particles are a paradox. They do not exist in the traditional sense, yet their fingerprints are found in every experiment. They blur the line between being and non-being, between reality and possibility, and still they are essential. Perhaps there's something beautiful in that the universe is built not just on permanence, but on fleeting sparks that live only for an instant. We exist, in part, because of things that are gone before they are even born. The Casimir effect, proof of invisible tides. For decades, the idea of invisible energy in a vacuum sounded abstract, almost mystical. But then came the Casimir effect, a quiet experiment that revealed the hidden tides of emptiness. It showed that even when you place two simple metal plates close together, the vacuum between them behaves differently, as though an unseen pressure is at work. In 1948, Hendrik Casimir predicted this strange force. He reasoned that vacuum energy is not uniform, that fluctuations of virtual particles are limited between the plates compared to outside. The result: the plates are pushed together by invisible pressure, a cosmic tide squeezing them in silence. Years later, experiments confirmed it. The plates really did attract, even though no light, no particles, no visible force acted between them. It was as if emptiness itself had hands, gently pressing. The Casimir effect became one of the most haunting proofs that the vacuum is alive with hidden energy. This discovery shook science. A force born from nothing suddenly had measurable consequences. Empty space wasn't empty at all. It was full of invisible tides, strong enough to move objects in the lab. The implications reached far beyond theory, into technology, nanomachines, even questions about the universe's birth. And so, with two metal plates and a delicate measurement, the veil lifted. The Casimir effect told us plainly: the silent ocean of invisible energy is real, and we are swimming in it every moment of our lives. How two metal plates revealed the unseen sea. It sounds almost comical. Two flat plates placed close together in a vacuum chamber. No wires, no magnets, nothing in between. Yet when scientists measured carefully, the plates moved toward each other. What force could possibly pull them together in perfect emptiness? The answer was unsettling: the unseen sea of quantum energy. The plates acted like barriers, filtering which wavelengths of vacuum fluctuations could exist between them. Outside, countless frequencies buzzed freely. Between them, only certain wavelengths fit. This imbalance created pressure, pushing the plates together. The vacuum wasn't neutral. It was restless, uneven, alive. It was as if the plates dipped into an invisible ocean. Waves crashed outside but were muted inside, and the imbalance nudged them closer. What seemed like a trick of math turned out to be a genuine force, a handshake with the unseen sea that fills space. The experiment was repeated with greater precision, and each time the result held. The plates always drifted together, as though carried by invisible tides. The Casimir effect became undeniable proof that vacuum energy was not a fantasy, but a physical reality pressing on matter. And if such small plates could feel the push of invisible tides, imagine what galaxies, stars, and black holes feel across the vastness of space. The unseen sea revealed in a laboratory might be the same force shaping the whole universe. Energy that pulls without touch. The Casimir effect revealed something unusual about invisible energy. It can pull without touch. Most forces we know involve something tangible: a rope, a magnet, a push of air. But here, no particles traveled between the plates, no material connected them, yet they moved. Pure, invisible energy did the work. This is what makes quantum vacuum forces so eerie. They act without carriers in the traditional sense. They come not from matter, but from the structure of space itself, energy that needs no messenger, no medium, only the restless vacuum whispering between objects. Think of two boats on a lake, gently drifting closer as waves slap their sides unevenly. You don't see the waves at first, but you see their effect. The Casimir effect is similar. The waves are invisible fluctuations, the boats are the plates, and the approach is inevitable, a pull born not from contact but from imbalance. For technology, this principle is profound. In the nano-world, where distances are tiny, Casimir forces become significant. They can make micro-machines stick together, shift delicate structures, even inspire new designs for energy harvesters. The pull of emptiness may one day power tools smaller than a grain of dust. And it all began with a realization almost too strange to believe. Space itself can exert a force, pulling without touch, proving again that the universe hides far more than it reveals. A laboratory glimpse into the hidden ocean. For centuries, invisible energy was the domain of philosophy and imagination. Then, in a quiet laboratory, it revealed itself under the gaze of physicists. The Casimir effect gave humanity its first measurable glimpse into the hidden ocean of quantum fields, a reminder that even small experiments can unlock cosmic truths. This glimpse was humbling. If empty space in a vacuum chamber could generate measurable force, then what about the infinite reaches of space itself? The laboratory became a window, and through it scientists saw that the very fabric of the universe is restless, creative, and alive with unseen activity. It is rare for something so simple to touch something so vast. Two plates on a table linked directly to the birth of galaxies, the expansion of the cosmos, the whisper of creation. It showed that the smallest tools could reveal the grandest mysteries, and it stirred wonder. If a human experiment can measure invisible energy in such a direct way, what other hidden forces wait to be touched, measured, understood? The Casimir effect was not just a proof. It was an invitation, a glimpse into an ocean still waiting to be explored. And so, a laboratory experiment became more than science. It became a quiet message that the universe's greatest secrets are not far away, but woven into the very air between our hands. The fabric of reality never rests. After all these discoveries, one truth grows impossible to deny. The fabric of reality never rests. It hums with energy, ripples with fluctuations, tugs invisibly on everything it touches. What looks like stillness is an illusion. The universe is alive in every space, every breath, every corner of nothingness. This constant motion is what makes matter stable, galaxies whole, and the cosmos dynamic. Without it, atoms would collapse, light would lose its rhythm, and space itself would freeze into lifelessness. The restless hum is not a detail, it is the foundation of reality itself. When you pause in silence and think you hear nothing, remember that beneath the quiet, every atom around you is quivering with the whisper of the vacuum. Stillness doesn't exist because reality refuses to stand still. Creation is an ongoing process, continuous and unbroken. Perhaps that is why the night sky feels alive, not because of the stars we see, but because the darkness between them is never truly dark. It is woven with unseen currents, unseen tides, unseen energy, shaping everything we know. And so the greatest revelation may be this: emptiness is not empty, silence is not silent, and the universe is not resting. It is alive, always alive, to scheme even when it looks most still. The link between invisible energy and time itself. Time feels steady to us, a constant flow from past to present. But physics reveals something subtler. Time is woven together with energy. The hidden energy of the vacuum may even set the tempo of the cosmic clock. Without it, time itself might unravel, losing the rhythm that keeps the universe moving forward. At the quantum level, fluctuations shape how particles behave, and particles, in turn, define how clocks tick. Every oscillation of an atom, every pulse of light, owes its reliability to the hum of hidden energy beneath it. Time is not separate from energy, it is carried on its back. Imagine a drumbeat guiding dancers. The dancers are the particles, and the drumbeat is the unseen energy. Without the beat, their motion loses coordination. Without invisible energy, time itself would lose coherence. What feels eternal is actually fragile, sustained by whispers too faint for us to sense directly. This connection means that when vacuum energy shifts, time shifts with it. Cosmologists speculate that in the earliest moments of the universe, time may have stretched, slowed, even fluctuated as invisible energy surged and settled. Our sense of linear flow may be only a local perspective of a far stranger process. And perhaps that is why time feels both familiar and mysterious. It is not just movement of hands on a clock, but the echo of invisible energy flowing beneath everything, shaping reality second by second. Why clocks depend on unseen vibrations? We trust clocks as the guardians of time. Yet beneath their steady ticking lies a dependence on invisible vibrations. The most accurate clocks we have, atomic clocks, work by measuring the oscillations of electrons within atoms. But those oscillations are not self-sufficient. They rest on the foundation of unseen quantum energy. Without the fluctuations of the vacuum, atoms would lose their rhythm. The electron's energy levels are nudged by the invisible buzz of space, fine-tuned by whispers we cannot see. Our definition of a second, the measure we use to order life itself, is shaped by forces beyond perception. Think of a violin string again. It cannot sing without the tension of the bow. In the same way, an atom cannot keep perfect time without the background hum of quantum energy. The accuracy of clocks, from a wristwatch to the satellites guiding GPS, owes itself to vibrations born of the vacuum. This is humbling. We often imagine timekeeping as a human invention, but really it is borrowed from the universe. We listen to the vibrations already written into matter, vibrations sustained by invisible fields that never rest. So, when you glance at a clock, you are not just reading numbers, you are looking at an agreement between humans and the hidden fabric of reality. A truce with the unseen vibrations that make time possible. Space as a reservoir of silent power. Space looks empty, but it is perhaps the greatest reservoir of power in existence. The energy packed into every cubic centimeter of vacuum dwarfs anything we can generate. If humans could harness even a fraction of it, we would never know shortage again. Yet this silent power remains untouchable, hidden behind the laws of physics. Physicists estimate that the vacuum energy in a small cup of space could outweigh all visible matter in the universe. But something keeps it in balance, preventing it from exploding into chaos. Space hoards its power silently, revealing it only through subtle whispers like the Casimir effect or cosmic expansion. This reservoir is not static, it breathes with the cosmos, shaping the birth of stars, guiding the expansion of galaxies, fueling the rhythm of time. It is the invisible treasury from which creation draws, yet it spends sparingly, never revealing its full fortune. It's strange to think we live inside such wealth. Every step we take, every breath we draw, we move through a vault of immeasurable energy. Yet it is so perfectly balanced, so evenly spread, that we hardly notice its presence. Perhaps the real marvel is not that space contains so much power, but that it holds it so gracefully. A silent reservoir that sustains the universe without ever breaking it apart. When relativity meets quantum whispers, two great pillars of physics stand side by side: Einstein's relativity, which describes the cosmos at large, and quantum mechanics, which explains the microscopic. For decades, they have struggled to merge, and at the center of that struggle lies the hum of invisible energy, where relativity meets quantum whispers. Relativity treats space as smooth, curved and continuous, bending gently under the weight of mass and energy. Quantum mechanics sees space as restless, foaming with fluctuations at every instant. Reconciling the two is like trying to fit waves onto a perfect mirror. The reflections never quite align. The vacuum energy is the battlefield. Relativity predicts one value for the energy of empty space. Quantum mechanics predicts another, one so vast it should tear the universe apart. The two answers differ by numbers beyond imagination, the greatest mismatch in all of science. Physicists call it the vacuum catastrophe. It is a reminder that even our most successful theories are incomplete. Somewhere, hidden in the hum of space, lies the bridge that unites them. We simply have not heard it clearly yet. And until we do, the whispers of quantum mechanics and the curves of relativity remain two halves of a story waiting to be told as one. Einstein's uneasy truce with the vacuum. Einstein once called the idea of vacuum energy his greatest blunder. He introduced it reluctantly, a cosmological constant, to keep the universe steady, then discarded it when expansion was discovered. Yet decades later, his abandoned constant returned, now wearing the mask of dark energy. The vacuum refused to stay silent. For Einstein, space was not nothing. It had geometry, curves, and weight. But he resisted the idea of it buzzing with invisible energy. It felt unnatural, inelegant, even absurd. He wanted a universe of smooth order, not restless emptiness, and yet reality defied him. The accelerating expansion of the universe proved that vacuum energy was not only real, but dominant. The constant he once regretted became the central player in modern cosmology. His uneasy truce with the vacuum became science's ongoing surrender to mystery. It's almost poetic. The greatest mind of modern physics humbled by silence, forced to admit that emptiness was more powerful than even he had imagined. The vacuum had the last word, and it whispered through the stars, racing away from each other faster each day. Einstein's struggle reminds us that even the brightest thinkers are only listeners, not authors, of the universe. And sometimes the quietest truths are the ones that overturn the loudest certainties. The cosmological constant's haunting return. Einstein once erased it from his equations, but the cosmological constant returned decades later, haunting physics like a ghost that refuses to stay buried. At first, it was a patch, a way to keep the universe static on paper. But when astronomers found the cosmos was expanding, Einstein called it a mistake. Only now we know it was no mistake. It was prophecy. The constant reappeared when scientists discovered dark energy. Suddenly, Einstein's discarded symbol looked like the perfect way to describe it, a quiet pressure stretching space. What he regretted became the very key to the universe's acceleration. It's humbling to imagine the greatest scientific mind uneasy with his own idea, discarding it too soon. Yet history brought it back unchanged, as if the universe itself whispered, "You were closer to the truth than you knew." The cosmological constant may not be the whole story. Perhaps dark energy is more complex. But its haunting return reminds us that sometimes knowledge arrives before its time, waiting patiently for the world to catch up. And maybe that's the real lesson, that the universe writes truths we can only half understand, leaving us to rediscover them again and again, like echoes that refuse to fade. Why the universe expands faster than expected. When astronomers studied distant supernovae, they expected to find slowing expansion. Instead, they discovered acceleration. The universe expands faster than expected. This was a shock. Gravity should have been tugging galaxies back like elastic, stretched too far. But something stronger than gravity was at play, a silent force winning the tug of war. Dark energy became the explanation, but it raised more questions than it answered. Why does it exist? Why now? Why at this precise strength, strong enough to accelerate, but not so strong that galaxies never formed in the first place? The timing seems suspicious, almost too precise. This puzzle unsettled cosmologists. They called it the coincidence problem. Why do we live at the exact moment when dark energy dominates, yet stars still shine? Billions of years earlier, it was weaker. Billions of years later, galaxies may drift apart into silence. We exist in the brief window when both light and expansion balance. It feels almost like being in a theatre just as the play reaches its most dramatic act, at the timing too perfect to be coincidence. Is it chance, or does the universe have hidden rules we don't yet see? The faster expansion is not just a curiosity. It is our fate written in the invisible pressure of space. A reminder that the cosmos may not simply drift forever, but race toward a destiny we barely understand. Energy woven into the fabric of space. The strangest part of dark energy is not that it exists, but where it exists, everywhere. Unlike stars or matter, which clump together, dark energy is woven evenly into the fabric of space. No matter where you go, no matter how far you travel, it's there, spread like mist across the cosmos. This evenness makes it different from everything else. Gravity gathers, stars burn, planets form in pockets. But dark energy does not clump. It fills the gaps, the voids, the endless stretches where galaxies do not reach. It is the background of backgrounds, the true canvas beneath it all. Scientists describe it as the energy of the vacuum itself, a property of space rather than a substance inside it. That means you cannot escape it, cannot outrun it. Space expands because dark energy is not within space, but is space, stretching silently everywhere. It's eerie to realize that we float not in emptiness, but in a field of invisible energy. Every breath, every moment we are carried by this woven fabric, moving without knowing the hand that guides us. And perhaps that's why the night sky feels both infinite and intimate. Because we are stitched into its fabric, threads in a cosmic tapestry held together by something we cannot see, but cannot live without. A balance between gravity and emptiness. The universe is a delicate balance. On one side, gravity pulls matter together, collapsing clouds into stars and stars into galaxies. On the other, dark energy pushes space outward, stretching everything apart. The entire cosmos exists in the tension between these two invisible hands. For billions of years, gravity dominated. Stars were born, galaxies grew, clusters formed. But as space expanded, dark energy began to tip the scales, slowly overtaking gravity's pull. Now the universe is ruled by this silent push, guiding galaxies into ever faster separation. It is a cosmic seesaw, perfectly tuned. If gravity had been slightly stronger, the universe would have collapsed into itself long ago. If dark energy had been slightly stronger, stars would never have formed. We live in the middle ground, the rare balance where light and life can exist. This balance is fragile and it will not last forever. Dark energy grows as space grows, and one day it may overwhelm gravity completely. But for now, we live in the golden moment, the age of galaxies, stars, and planets made possible by a delicate truce between gravity and emptiness. And that thought carries both humility and wonder, that our very existence depends not only on matter, but on the silent balance of two invisible forces we can neither see nor control. The strange equilibrium that keeps us here. If you think about it, our entire existence rests on equilibrium. Not just biological balance or planetary orbits, but the strange cosmic balance between forces we cannot see. The universe has arranged itself in such a way that both collapse and chaos are held at bay, at least for now. This equilibrium is uncanny. Why should dark energy and gravity be so precisely matched that the universe is neither falling apart too soon nor never forming at all? Some call it fine-tuning, others call it chance. But either way, the odds of such a balance are staggering. For us, it means life is possible. Stars burn long enough for planets to form, chemistry to unfold, and minds to wonder about it all. If the equilibrium tilted even slightly, none of this would exist. No galaxies, no Earth, no human gaze at the night sky. It feels almost like walking a tightrope across infinity, each step possible only because the forces beneath us cancel just enough to let us pass. The strange equilibrium holds us suspended in the middle of eternity, delicate yet enduring. And when you look at the stars tonight, remember this. We are not here because the universe is simple, but because it is balanced in ways stranger and subtler than we may ever understand. Invisible energy in the birth of stars. Stars do not simply appear, they are born from clouds of dust and gas collapsing under gravity. Yet gravity alone cannot explain the process. Invisible energy plays a quiet but decisive role, guiding how these stellar nurseries ignite. Within molecular clouds, subtle fluctuations of pressure, magnetic fields, and quantum whispers shape where collapse begins. At first, a cloud may resist. Turbulent motions and hidden energies keep it puffed up, preventing collapse. Only when these invisible forces shift, when balance tips just enough, do pockets give way, shrinking inward until nuclear fire sparks. The birth of every star depends on this delicate, unseen battle. Even in their earliest stages, invisible currents influence how stars cluster, how many siblings they form, and how long they burn. Magnetic fields thread through them, sculpting their collapse, while quantum fluctuations decide the density thresholds. What looks like chaos is, in truth, shaped by quiet rules written in hidden energy. Without these unseen influences, the universe would have been different. Stars might have been too massive, burning out too quickly, or too small, never igniting at all. The invisible hand of energy set the stage for suns stable enough to cradle life. And so when we look at the night sky, we are not just seeing stars. We are seeing the outcome of a silent dialogue between gravity and invisible energy whispered across eons, choosing where light would first shine. Clouds collapsing under silent pressure. Star-forming clouds may look serene in photographs, glowing softly in cosmic colors, but within them lies turmoil, clouds collapsing under silent pressure, shaped by forces we cannot see. Gravity tugs inward while radiation pushes outward, and in between lies the unseen contribution of the vacuum itself, influencing the balance. It is like watching a storm gather. Winds swirl invisibly before raindrops ever fall. In the same way, star clouds swirl with pressures invisible to the eye. Some regions collapse quickly, birthing massive stars. Others resist, held up by silent energy threading through them. Astronomers have found that these invisible pressures are not uniform. Magnetic fields, remnants of early fluctuations, carve pathways through clouds. Some filaments tighten, others remain suspended, delaying collapse. Without these subtle forces, the stars we see would not be arranged as they are, nor would galaxies have their shapes. This collapse is not chaos, but choreography. Silent pressure guides which regions ignite first, which cluster together, and which wait their turn. Over millions of years, these whispers sculpt constellations, long before any human eye looks upward to name them. And when you realize this, the beauty of the night sky deepens. Each star is not just a point of light, but the child of invisible pressures that collapse to cloud, quietly deciding where light would emerge in the dark. Light emerging from dark cocoons. The first breath of a newborn star is hidden, cloaked in darkness. Thick clouds surround it, trapping light inside. For thousands of years, it glows unseen, cocooned in dust. Only when invisible energy shifts, heating, pushing, carving pathways, does the cocoon break and light escapes for the first time. This emergence is delicate. Too much pressure and the star suffocates, never shining. Too little and it disperses, fading before it begins. Invisible balances within the cocoon decide which stars survive, which burn, and which dissolve back into the cloud. Each point of starlight in the sky is a survivor of this hidden trial. Infrared telescopes allow us to peer into these cocoons, revealing the hidden stars before their light escapes. We see jets of gas bursting out, channels carved by invisible magnetic energy, clearing paths for light to travel outward. Without those unseen forces, much of starlight would remain trapped forever. What's haunting is that our own sun was once hidden in such a cocoon, burning quietly before it broke free. The warmth that sustains us today was once imprisoned in darkness, waiting for invisible forces to open the way. And so, every sunrise carries a memory. That light emerges from darkness not by chance, but because invisible energy carved the passage that allowed it to shine. How hidden energy shapes stellar nurseries. Stellar nurseries are vast, glowing clouds where stars are born in clusters. But the way they form, their density, their patterns, their survival, is shaped more by hidden energy than by what we can see. Gravity gathers, but invisible currents sculpt. The result is the cosmic equivalent of gardens, carefully pruned by unseen hands. Astronomers studying the Orion Nebula find filaments, arcs, and voids shaped by pressures no eye can detect. Magnetic fields guide collapse into strands. Quantum fluctuations ripple through the gas, deciding which clumps ignite. The nursery is not random. It is ordered by whispers in the unseen. These hidden energies also decide the fate of planets. The size of a star, its lifetime, its habitability, all are seeded in the nursery. Invisible forces determine whether worlds like Earth are possible or whether systems collapse into chaos long before life has a chance to grow. It is humbling to realize that our solar system was once part of such a nursery. Our sun's formation, our planet's orbit, our existence, all emerged from a cosmic womb, shaped by energies no telescope can yet see, but whose fingerprints are everywhere. The nursery becomes more than a cluster of gas. It becomes the silent architect of life itself, proving again that what is unseen often carries the greatest weight. Even black holes hum with quantum whispers. If any place should be silent, it is the heart of a black hole, a region where light itself cannot escape, where time and space collapse inward. Yet even black holes hum with quantum whispers, defying the silence we expect. Stephen Hawking showed us that even these giants glow faintly with radiation. Hawking radiation arises from quantum fluctuations at the edge of the event horizon. Virtual particles appear, one falls in, the other escapes. Over eons, this trickle of energy causes black holes to slowly evaporate. Even the darkest objects in the universe cannot resist the whispers of invisible energy. This discovery was shocking. Black holes were thought eternal, devourers that only grew. But invisible quantum whispers proved otherwise. They decay, they fade, They glow softly with a radiation too faint for human eyes, but undeniable in theory. It is a reminder that silence does not exist, not even at the edge of eternity. Where we thought darkness ruled without exception, invisible energy still found a way to sing, however quietly. The universe refuses to give up its hum, even in its most terrifying places. And perhaps that is the most beautiful truth of all, that even black holes, symbols of finality, are not beyond the reach of the invisible energy that fills everything. Even in the deepest night, the hum continues.